An old fire extinguisher, something most people would simply throw away or sell as scrap metal. But what if it could be transformed into a compact pyrolysis furnace capable of producing high-quality charcoal? Today, I'll be turning discarded materials into a practical new tool. Will this homemade pyrolysis furnace actually work and produce the charcoal we're hoping for, or will it end up being a complete failure? Stay with me until the end of the video to find out. After cleaning the fire extinguisher and drilling a series of small holes in the bottom for the initial airflow, I marked the upper section of the cylinder and carefully cut it in half. This section will become the removable lid, so it's important to make a clean, accurate cut to ensure both parts fit together as tightly as possible. Instead of fabricating new hinges or additional hardware, I decided to reuse the retaining ring already attached to the bottom of the fire extinguisher. It serves as a simple connection between the lid and the main body, allowing the lid to open and close smoothly while saving both time and materials. With the fire extinguisher finished, it's time to build the combustion chamber. For this part, I'm using another old pressure tank. The first step is removing all the unnecessary external components and cleaning up the surface so it's ready for fabrication. Next, I cut a circular opening in the combustion chamber that's almost exactly the same diameter as the fire extinguisher. A tight fit is essential here because it minimizes gas leakage and helps maintain an efficient pyrolysis process. Once the upper section is complete, I cut a small opening near the bottom of the combustion chamber. This will become the firebox, where fuel is added to generate the heat required for the pyrolysis process. To make the furnace as airtight as possible, I fabricate a small access door for the firebox. Besides reducing heat loss, this door also allows me to regulate the airflow, making it much easier to control the furnace temperature during operation. The next step is joining the fire extinguisher to the combustion chamber. During this process, it's important to pay close attention to how deeply the fire extinguisher extends into the chamber. If it's inserted too far, it will reduce the combustion space and negatively affect the furnace's heating efficiency. After securely welding both sections together, I add a vent to the top of the combustion chamber. This improves airflow whenever the furnace lid is open. I also make a removable cap so the vent can be sealed whenever an airtight environment is needed for the pyrolysis process. Now that the entire build is complete, it's finally time for the real test. Let's load the furnace with wood and see whether this homemade mini pyrolysis furnace can actually produce high-quality charcoal as intended. After about 30 minutes of heating, the temperature inside the furnace rises significantly. Moisture trapped deep within the wood begins to evaporate rapidly, producing thick white smoke that pours out from the top of the furnace. This is a clear sign that the wood is heating properly and the pyrolysis process has begun. After approximately 1 hour, the smoke gradually changes from white to a pale yellow or bluish-gray color, accompanied by the sharp, distinctive smell of wood resin. This indicates that it's time to seal all of the natural air intake openings, creating an oxygen-limited environment for the pyrolysis process. The furnace is then left to cool naturally for about 3 to 5 hours. Once the outer shell has completely cooled, it's time to open it up and collect the finished charcoal. Thank you so much for watching. If you enjoyed this project or found it helpful, don't forget to leave a like, subscribe to the channel, and turn on notifications so you won't miss any of my future DIY projects. See you in the next video.